everybody. Welcome to OpenCV Weekly webinar. And today we have with us Vikas Reddy, who is the CEO of LightTwist. And this is the company that helped us build this amazing set for OpenCV AI Game Show. And we'll learn what went behind the scene to create that set and the technology behind it. And also with us is Phil Nelson, who is the Director of Content and Creative at OpenCV.org. Vikas will come to you in just a minute. I'll let Phil say a little bit about the show and the format.
Yeah, hey everybody, good morning. It is I once again, the co-host with the co-most, the second banana who is second to none, the plus one and only Phil Nelson. I'm here to remind you about a couple things we do every day here on OpenCV, every week here on OpenCV Weekly Webinar, which is a special giveaway to you in the audience. Stay tuned later in the episode. We will ask a trivia question based on the slides from Vikas here, and you'll be able to win. Well, tell them what they'll win, Satya.
Well, they will win one course, OpenCV for beginners. And if you have already taken that course, then you can opt for Computer Vision 1.
Awesome. Great value there. Obviously, it's always good to invest in yourself and your education, and one of the best ways to do that is with OpenCV courses. Vikas, I think we've also got a giveaway from LightTwist. You want to tell them what they might get there as well?
Yeah, so we're going to give away so we're just starting to roll out very early access to the LightTwist Mac app, which is what I'm using right now for this call, and we're going to roll in a customized studio as well. So essentially, you get early access to the app plus a customized studio where you can add your logo, your name, your favorite sports team, like whatever you want in the space. So yeah, can make you look amazing on Zoom and
super awesome. Yeah, great. Those in the audience, if you're not in the Zoom audience, get in the Zoom audience. You can join at opencv.live. Those giveaways will be available only to folks that are joining us here on Zoom due to latency issues with the other, kind of systems. The other thing we do is Q&A from you in the audience. So please use the little Zoom Q&A button at the bottom of the screen there at any time during the webinar to ask any questions you have about the show, and we'll do our best to answer them in the course of the show. And if we have time at the end, we'll try to get to any that we couldn't get to during the regular course of the show. I said everything twice there for some reason. Satya?
Well, one of the things that you should notice, people who are going to be introduced to the magic of LightTwist is what you're looking at, Vikas's video. It's the background is not real, right? But we have seen, obviously, we have all seen people removing background in Zoom and other software. But look at the quality of this. It is almost alpha matte quality, where you're not doing real segmentation, but you're not doing segmentation, but you're doing alpha matting, which is at the boundaries, you are going from 0 to 1 instead of having a hard 0-1 segmentation. So not only that, the lighting looks very consistent. So it is, if we had not told people, it is very easy to fool, right? With this technology, it's pushing the boundary. We are almost there that you can fool people for, there could be a minor defect here and there once in a while, and it will give a giveaway. But for the most part, even while watching the AI game show, there were times where I completely forgot that this is not a real set, right? So great job there, because it's your show now. We'd love to see. First, I mean, it would be nice to get a quick introduction, and then you can start with your slides.
Got to have somewhere to put that lower third, man. Yeah.
Maybe I'll I'll do a quick behind the scenes of this actual webinar here. So this is like my actual real space here. So yeah, not as exciting, but yeah. Sometimes, to your point, Satya, I actually sometimes forget that I'm sometimes when I'm on Zoom, I'll like turn off my thing. I'll be like, oh right, I'm just in my like crappy little basement office here. But yeah, no, it's a quick quick intro on LightTwist is we're basically letting people we're building products that let you stream and record video in an interactive 3D studio. And we were really heavily inspired by the incredible work that was done on the Mandalorian, where they were really doing this pretty groundbreaking work in mixing advanced game engine spaces using Unreal Engine with real actors and doing an amazing job of compositing. There, they built up this whole physical stage, but
Yeah, and a bunch of
yeah,
real furniture and props and
yeah,
rocks and stuff as well. I think one of the things with that show that was so awesome is they learned the lesson from the prequels, as it were, where you can do the virtual production like almost entirely virtual, but for
yeah,
these high-end Hollywood movies, you kind of want some real stuff in there too to give it that verisimilitude. They're like, oh, that he kicked that rock and that's a real rock.
yeah,
Matters when you're supposed to be on a different planet and you paid
yeah.
$25 to see this movie.
At least for now. Maybe down the road we'll get to a level where you won't even need the you'll have some aspects of that practical effect. But
You
yeah,
can
no, it's
you can break your toe on a virtual rock.
yeah, exactly. But yeah, that's where we're at. We're a small team. Yeah, we'll talk about we're actually hiring to grow the team now. But yeah, we've yeah, it's been an exciting. I think it's been about maybe 11 months or so, or maybe even just about a year since we last talked, since I was last on the show. So made a lot of progress thanks to the team at LightTwist. So yeah, excited to be back here today.
Yeah, thanks for being back. This is going to be great. It was
Yeah,
a lot of fun working on this show. It was a lot of stress, but a lot of fun.
yeah,
I feel like
yeah. We'll talk
anything
about
that's
some of
worth
the
yeah, anything that's worth doing is probably not going to be easy. So
yeah. So I guess I'll jump in. Yeah, Satya, Phil, anything else, or should I get into it?
it's all
Let's
yours.
get started.
All right, sweet. Let's do this. Now, let's hope this works. Okay, I'll share my screen here. I'll play
Hey,
this.
yep,
How's
that's
that
good.
looking? Looks good?
Hmm.
Okay, awesome. So, yeah, just wanted to take you behind the scenes, the OpenCV AI Game Show. Um, and yeah, really the thing that's pretty crazy about this is actually we did it. Satya and Phil reached out about putting on this game show. Personally, I just thought it would be a lot of fun to work on, and like I wasn't even thinking about exactly how this would turn into something that we would do long term. But from actually doing the show, we actually learned hit a bunch of issues, which we'll talk about later, and it actually inspired the creation of a cloud version of LightTwist. So we'll talk about that. But yeah, it was a pretty awesome endeavor. So
We
yeah, first
we
of all,
try to be inspirational.
yeah, extremely inspirational. But yeah, that's like some of the stuff that happens in startups when you're in the 0 to 1 phase. There's a lot of things that you connect the dots in reverse or not forward, as Steve Jobs said, where you just like do some stuff, you try a bunch of different things, and then some things that you weren't even sure were something that was like a good long term thing that you should be focusing on turns out to be an interesting inspiration. So yeah, and so here this is just like a couple examples from what we're doing with LightTwist. So on the left is just I guess we talked about that already, but
Hey friends, Vikas here with LightTwist.
yeah, this is like showing off using an iPhone for the camera for Zoom. We've got like a nice. This is like from our LightTwist Mac app. It has a
as you can see, I'm in my storage room office and using the built-in webcam on my MacBook Pro. A pretty huge.
And then yeah, to Satya's point, you can see like the some of the stuff that we're working on there is like taking some of the most recent state-of-the-art algorithms around segmentation and matting and figuring out ways to get them to run on in real time on just a Mac instead of having to use like a nice RTX graphics card. And yeah, you can see some of the things around like the hair and the edges that are much more accurate and representative of what reality looks like, as well as the stability over time, some temporal stability of the segmentation. So some of the things that we're working on there. And then there's also like they're doing some pretty low level integration with Unity and virtual cameras. So using some pretty cool low level stuff like shared textures and being able to reduce the number of copies of images across the pipeline. So the background and the studio itself is rendered by Unity there, but the whole space is composited in a native Mac app. So yeah, just an example of some of the stuff we're working on.
Those like the last mile problems with thin hairs and stuff like that is really it's been a problem for 20 years to accurately get people's hair to look decent. In a lot of movies, they just still fake it. They give them like fake CG hair stuff sometimes. It's crazy.
yeah, to like make up for it. Yeah, it makes sense. And this is just like we'll talk about the show. Obviously, this is like a teaser that we recorded, but this is more using higher end software or higher end like hardware. That's using higher end hardware, using like a nicer version of the same segmentation algorithm, and rendering using like Unreal Engine, which has some, at least in our experience, some nicer graphics capabilities. So yeah, as discussed, like, really at a high level, what we're really doing is like taking a bunch of things that are possible today if you have the right equipment, you have the right knowledge. And there's this whole space of virtual production that's was something that I got into sort of on accident. Like a friend pointed me over to it and was pretty mind blown at how they were doing this on The Mandalorian and other examples. Really combining game engines, especially Unreal Engine, with real world actors. And you can see some of what Phil mentioned in the top left there, where there's like a real world actor on like some practical, meaning like actually physically built stuff, but then the actual the space itself is all synthetic and generated
on these gigantic. How much do those LED panels cost, do you think?
I mean, the individual ones are probably just, I think they built it on commodity panels, but it's like, I forget how many they had, but I'm sure the whole stage that they created this whole 360-degree stage for it. And I'm sure it costs like, tens of millions is my guess.
Right.
I'm actually curious to know how many GPUs they use. I don't think I ever got that exact number, but
the answer is just the infinity symbol.
Yeah. But yeah, in some sense, we're like letting you, our goal is to like make this technology available and accessible to people that don't have the budget of Industrial Light and Magic. So using more, commodity hardware like iPhones and others for the capture side, and then using, using smart software and UX to essentially simplify some of the things you'd have to do if you were trying to use Unreal Engine or Unity directly for this. But yeah, this is just something we talked about a year ago. But what's really interesting is like there's a bunch of different technologies that are converging to make this possible. So one is just obviously very relevant to this show and channel is like as you've all seen, I'm sure over the last couple of weeks, even in webinars, like there's been an incredible advancement in 3D computer vision. So being able to use both essentially being able to do things like segmentation, doing things like relighting. There's all this work in NeRFs now. So like neural rendering, we're able to render even people and objects from different angles.
Yeah, speaking of which, the winners of OpenCV Spatial AI contest did a NeRF-based project.
Oh, nice. That's awesome. Yeah, I mean, we're not quite there yet. We're still, just trying to nail a couple other things around segmentation and lighting. But I think doing something with NeRF and 3D reconstruction is something we're excited about at LightTwist, because I think it's required to enable some more advanced interactions and even camera motions we'll talk about later. And yeah, the other thing is like just camera quality is like I would bet today that if you give the average person a $10,000, the most expensive like lens and whatever setup on a DSLR, and then you give them a iPhone 13 Pro or like whatever the latest one is, like then I would bet that the person with the iPhone 13, the average person with the iPhone 13 Pro is going to shoot a much higher quality video, because a lot of the things that you do manually have been now encoded into software. So basically, yeah, the iPhones and other smartphones have gotten this really interesting combination of both much improved hardware, but also really interesting computational photography software, and pairing those together in a way that like gives you essentially DSLR-like capabilities, or even like, in some ways stretching the boundaries of even what you're able to do with RED cameras and more advanced ones. And then they also have built-in compute for being able to do things like tracking and 6-stop tracking. So pretty incredible. And then the other thing that we get to just basically get for free is the incredible graphics capabilities of modern game engines, like especially Unreal Engine. Just an example there on the right, but it's like some of the most, if you look at some of the nicer studios and spaces and environments that are built in Unreal Engine, it's getting really harder, a lot harder and harder to tell that it's not real. It's actually, I definitely, after seeing some of the more advanced ones, especially with Unreal Engine 5, I was like, okay, I can kind of see how taking this, you know, to the natural conclusion gets us to like we're living in the Matrix and some, you know, it's like it made me more increase the probability in my mind of like this whole like we're living in a simulation theory, because I was like, okay, basically, you know, a couple orders of magnitude better, and we might be there.
And the other thing is haptics. Haptics just kind of suck right now. Like
that's true.
You know, feedback for like feeling stuff,
yeah,
just it still is like very nascent. There. It's new. Yeah.
But it might get there at some point. So yeah, like this is like, you know, just talking about the show. So this was the challenge. So we had, you know, talked to Satya and Phil, and we were, you know, the goal was to create like a Jeopardy style game show. So we were looking for something that looked like Jeopardy in some ways.
Inspired and originally, to take it back even a little bit further, originally we were just going to do it on Zoom, right? It was just going to be,
that's right, yeah.
It was just going to be, you know, like we had this thanks to OpenVino, the OpenVino toolkit from Intel. We had this opportunity to do this show with a sponsor, and we were just going to do sort of like the webinar, except with, you know, guests and you know, like buzzers and stuff. And it just so happened that I knew this guy Vikas that I'd worked with who was doing a thing. And so
it was like I said before, it was like something that we were like, oh yeah, you know what, I'm not sure if this like really intersects with our product roadmap, but like seems like a really interesting thing to try out. So yeah, we had three people in the Bay Area, so two in SF and maybe one elsewhere, but maybe all in SF.
It ended up being the Kat and Joseph ended up and me ended up being in SF.
Yeah, in SF. And then we had myself in Boulder, and then Luna, who's the host of the show, was in Chicago, and then later I think Paris, perhaps. When we had to
we almost had to do reshoots for her on her vacation in Paris. Yes, her workcation in Paris that she'd booked like a year ago.
And then the other challenge is modest budget in quotes, where it's like we didn't have like, you know, tons of dollars to go. You know, I think if you go and like rent a studio out of the same quality of what you'd have for Jeopardy, it would be like, you know, on the order of like 20 to 30, probably 50K a day or something crazy like that.
Yeah.
Not to mention like flying everybody in and getting a videographer.
Well, I mean, you'd have to pay. You'd need grips and stuff for that. You'd need a whole crew.
Yeah.
And also, Vikas is being very generous in saying that we had a modest budget. LightTwist did this thing for us for free. So thanks, Vikas. I just want to acknowledge that.
Yeah, no, it was like I said, it was like a learning opportunity for us, and I thought it was it seemed fun. So yeah, it was just like more just like the overall, you know, goal here was to put something on that was like much better than what you could do on Zoom, but like in the spirit of something like Jeopardy, but without the resources you have to like put on like a Jeopardy style show in real life. So yeah, like some of the things that we planned out. So one was originally the way we had this done was we were using Zoom for running the show. So we were all like, you can kind of see me in the top right there on camera, like having talking to everyone else and being able to look at the questions. And then we were essentially all trying to record locally, so we'd have like a higher quality video. We took this virtual studio was like an existing asset on the Unreal Engine asset store, so we purchased that and then figured out how to just did some customization, so like the OpenCV logo, added a bunch of stuff from Intel and others, and then also placed and created all these virtual cameras. These are it's pretty fun. In Unreal Engine, they actually get represented as these movie style cameras, which is pretty fun. And so you can see all these different cameras that were essentially created, and in a sense, like doing what this enabled us to do is do some of what you would do as like a video producer, as a
literally picking up cameras and moving them around. Like
exactly. It's and not just like putting them in static locations, but animating them as well. So that it's kind of like in some sense, instead of doing the videography at runtime, being able to do this before or even in post-production, which is cool. And the other thing we did was just to make sure that the scale was properly constructed. We have these mannequins for scale. So we actually asked everybody what their height was and used that as a guide to ensure we were doing the scale properly.
Correction, those terrifying mannequins for scale.
Yeah, this is like one of the things that's interesting with I mean, with all game engines, it's like obviously it comes from the game world, so these are all like first person shooter style
Yeah.
characters, I guess. Yeah,
They're
for
very
better or for worse.
Terminatory or like almost militaristic for our
Yeah,
fun
yeah,
little game
exactly.
show.
Yeah, they're usually like they usually have like a gun in their hand or something like that. So, but yeah, that was like the set creation. And then yeah, we use like we actually we planned on using essentially just running this offline. So, using pre-recorded footage instead of running it live like I'm doing on this in the Mac app right now, doing it offline. So, and there's some advantages to that. Like we can run higher resolution, higher quality. We can set the settings to essentially dial up the settings so that it's higher quality, but it takes longer to run per frame. So,
Yeah,
an
and,
example of Luna here.
Luna's hair here is what I want people to really pay attention to, because this is the sort of thing that even just a couple of years ago would have been a way more difficult problem, and maybe not even possible with the tools we had available. But here it's like very very tight and very very clean on the edges on
Yeah,
a real person's hair.
yeah, and it could be better too. I think we're still can see some issues like on the bottom middle there. Like there's a bunch of stuff that we're still working on. And to be honest, I actually when starting LightTwist, I was like, okay, I'm going to assume segmentation is a fully solved problem, because like just seeing results out in the wild was like, okay, it seems like we're good enough. But yeah, there's a bunch of stuff where it's
no, the last mile is very difficult in segmentation. It's very easy right now. The state of the technology is that's very easy to get to a point where if you look at a single frame, it looks fine, right? But that's not what people expect when you're doing video production. It has to be perfect. You miss a few pixels here and there, and the virtual reality aspect of it is completely gone. And for that, the demands are very high, right? And the way people solve it in the movie industry, even now, they literally paint every frame, right? Any mistake in a frame will be literally painted on, right? There's a Photoshop artist who's zooming into
There's a
this
person
frame.
going through all 120 frames a second and a hand adding stuff. I know. I've met some of them. In fact, one of my old friends worked for Weta, the Peter Jackson's studio.
Yeah. And you could have people working on a 10-second segment for the entire year. That's what it takes, right? So this is a very difficult problem because it takes even experts so much effort to put in, right? And make it perfect.
Yeah, that's actually one of the things that we are working on right now. It's not quite ready. Is one of the things we discovered and realized is like it's having a little bit of human input, we think is actually pretty interesting. Where it's not just even when running the algorithm in real time, enabling a person to fix up certain issues is something that we're actually pretty excited about. Because I think that's one thing that I always found frustrating with actually a lot of real-time algorithms, computer vision algorithms, is that like they're typically presented to the user without any as a black box. And if it worked perfectly, then that would be fine. But in this intermediate state, until we're like there, we're looking at different ways to sort of to essentially let the user correct things. So if it's like, hey, the algorithm, this one of the issues we have right now is like sometimes certain objects will appear or not appear in the foreground. So headphones, like some chairs sometimes, and letting the user choose like where how they want that to appear. Do they want some certain things to be foreground, certain things to be background? Are there certain things that are a mistake? So that's something this sort of in a sense, like having human input and then leveraging that human input greatly with deep learning. So like taking that input and then running with it and actually doing a much better job is something we're really excited about.
Yeah, that human machine collaboration. Instead of just replacing this whole process that a person would be doing manually with a computer, you have the computer do the stuff the computer's great at, and then you have the person do the stuff the person's great at.
Yeah, and some of it's a user choice too. It's like, do I want my chair to appear or not, or my headphones? So it's really sort of a question there.
Yeah, and you can see that in Zoom also, right? If you put a coffee cup right next here, it won't segment it out.
Yeah.
But if you put it like this, your hand is gone, your coffee mug is gone. It looks very unrealistic.
Yeah, exactly. And there's in their case, like they had to go for a segmentation algorithm that sort of is sort of lowest common denominator, which makes sense.
Yeah.
Like meaning has to run across all these different platforms. But yeah, for us, we're picking like a smaller device support matrix, and then part of the we'll talk about this cloud version, but that's one advantage is we don't have to worry about device support. We can just run a pretty nice algorithm in the cloud. So yeah, here one of the cool things that we did was and it's a general virtual production technique. It's not like we invented this, obviously, but like one of the things that actually adds a lot of realism is subtle motion. So if you look on the one on the left, the camera is actually not moving that much, but just even that slight motion adds a lot of both visual interest and realism. So in some sense, matching what a videographer would do on set. If you have like a handheld camera or even like a camera on a rig.
Just makes it feel more organic and real because, real life is not static. Real life is
exactly.
Messy. Stuff moves around.
And then on the right, this is more of an extreme motion that we were able to do. And there's some issues that we had with it, but it was, what's cool is like, we more or less had like full control of like being able to animate those cameras ahead of time. And then trigger them whenever we wanted to.
Ding, sponsor mention.
Yeah, that's right. That was a good.
One thing that I was actually surprised by, and this you can only know after looking at the final footage.
Yeah.
I was not 100% sure that when you moved, the camera like that, it won't feel unreal. It doesn't,
because of the perspective.
Because the person is so far away that you can actually the perspective changes are
minimal,
are forgiving. Yeah.
Exactly.
So that is also very interesting.
Yeah, this is actually one of the things that this is part of the reason one of the main reasons I'm really interested in 3D reconstruction and things like NERF is for that reason. So yeah, here there's some limitations because we're effectively treating people as like 2.5D. They're not like we're not representing them as full 3D, full 3D in the scenes. And there are some companies working on that in various ways, but so far, nothing that's like that passes sort of the uncanny valley. Usually it's a little bit hard to, you look at it and you're like, okay, it's a little bit, there's weird stuff going on. And like, typically just like using like a traditional path where you like try to get a depth map and then, use that to create a 3D representation, it doesn't work. And so, but some of these NERF-based approaches are actually, they're working incredibly well for static objects. And then there's been a lot of work in upgrading them to work with people, of course. And so I think there's in some sense, like right now, if you imagine like, Luna here is like a 2.5D, essentially like, person in the scene as effectively a plane. There's some limitations in terms of like angles and different things you can get and how far away you are when you get those angles. But if you improve that representation even a little bit, then you can start to build some more extreme angles and have some more freedom. And then the most extreme version of that is like, oh, it's a full 3D representation, and then you can do whatever you want. But I think we're a little bit further away from that.
Yeah,
I've seen some demos recently. Yeah, go ahead, Steve.
So one other thing that I wanted to point out is for people who are interested in research in this area, is that sometimes you don't need the full 3D representation. So, I have this, I just got this Matterport device for scanning for a project. And one of the things to keep in mind is that the 3D structure could be very wrong, but you can still get a perfect visualization, right?
That's right.
So it is possible to, visualization is related, but not 100% dependent on the 3D structure that you evaluate. Right. You can have a wrong 3D structure or approximate 3D structure and still have stunning visual rendering of the scene, which is indistinguishable from, that it is unreal, right?
Yeah.
So that's something to keep in mind.
Yeah, and in fact, that's one of the things that, that got me, when I saw the original NERF paper back in, I think it was 2020, that got me excited about that is like, it's unclear how, and I will say, like, even with some of the more recent neural rendering approaches, like even the underlying 3D reconstruction seems, I haven't tested them extensively myself, but some of the results look quite good even at that level. But yeah, to what you just said, Satya, like part of it's like, but even just the value of like having, taking hundreds of photos of a person or a space and being able to re-render that from novel viewpoints is like, there's entire companies built on that, like Matterport. So I think it's going to be groundbreaking. Yeah.
One of the first papers I had implemented way back when I was a grad student, I think 2001, 2002, was this thing called view synthesis. You should look it up. Yeah, it was a paper by Steven Sides. And view synthesis was basically, they would take two pictures, let's say of two different people, and it would synthesize, it would morph between, actually it was not called view synthesis, it was called view morphing. So it would morph between the faces between these two people, but in a very realistic way. It is not just, it is morphing.
Like a crossfade or something, yeah.
Yeah, it wasn't a crossfade. It would be almost like a person looking down, and if the other person was looking up, it would do this motion. It would actually, the in-between person would do this motion. You should look up that paper.
Reminds me of the Michael Jackson black or white video.
Yeah.
And
date myself funny. There.
It's funny that a year or so after, I implemented this paper for my class project or something, I had a chance to meet Steve Sides, and I was so, in awe of Steve Sides that I did not even ask him a single question. I'm sitting next to him, eating dinner in a group. But I did not ask him a single question. I did not talk to him, did not do anything. I was just in
You're just
awe.
Fanboying out. You're just like, don't be weird. Don't be weird.
Yeah, I've definitely had that. I've had that happen before. Yeah. So like, and then the other thing that this is something that we get.
Speaking of weird.
One of the advantages of working with really nice game engine is like one of the reasons I'm excited about is like. You get to essentially, if we're handling aspects of like bringing real people into these game engines in a compelling way, then you actually get some things for free, which are pretty awesome. So like, this is just an example of like the real-time reflection. So look at the podium there, and it really enhances the realism of like him being in that space. Is you see him reflected in real time. So the game engine itself is like, we didn't have to do anything super fancy. We just like made sure the surface was glossy, and like, obviously his segmentation, his lighting is good, matches the scene more or less. But that's some of the fun stuff that's like, you get to take advantage of when you're using a game engine, and then it really enhances the realism because that compositing effect feels a lot more real, even within the space itself. So you see like the back, that sort of back panel is even reflected on the space, but the real time part's really, really fun.
Absent context, it sort of looks like Joseph is doing a Bela Lugosi kind of Dracula.
Yeah. We can sort of dub that in later. And so, yeah, I mean, so with all those plans, like, we had this like expectation that everything was already perfect. But then the reality is like, we hit a whole bunch of like random problems as expected. Or I should say, my expectation was, okay, cool. We planned this out really carefully. It's going to be amazing. And we're done. Should be pretty straightforward. We'll get it done. And then there's just a whole bunch of things that we hit. So a couple things like, actually one of the more, impossible to sort of fix issues was like, there's at least 2 or 3 people where either we had like missing footage. So some of the footage that we thought was recording actually wasn't recording. There's a couple of cases where people were not being framed properly. So like, one of the limitations with what we're doing is like, if you can't really, even if you have the best segmentation algorithm and everything else, like if the person goes out of frame or out of the field of view, like there's not much you can do there. I mean, maybe down the road with some resynthesizing some images or something, but like that was a major problem. And then we actually had, I would say like in the first take, we actually had some good back and forth. It was like kind of natural and felt pretty good. But the retakes definitely, it's one of the things that we can fix up, that we're looking to fix up down the road is like the natural back and forth like wasn't quite there. Because when you retake a scene, it's like, you don't get that. Another thing was like this was one we weren't actually able to fix for the final footage, but the segmentation on Kat's hair was bad. And looking at the original footage, it was a large reason for that was her hair was overexposed. So she had like fairly light hair, and then her given the sort of exposure settings of the camera, it was overexposed relative to the background as well. And so when things are washed out like that, like even if you had a human trying to manually segment, it would be fairly impossible. So it was interesting. Another thing was, yeah, like the buzzers were hard to manage. We were trying to use some just third-party software, and it was, and this is not even to the level where we're trying to hook it into the studio just yet, but just being able to do that well was something.
Yeah, I went through like probably 10 different buzzer solutions, and we finally, picked one, and it still was kind of a pain in the ass. Like it still wasn't really, it was not smooth, but it's,
Yeah, and actually, and also there was an advantage. I think in the first pass, I think Joseph had a slight advantage because he was in Iowa, and I think they must have, maybe they were running their buzzer in ET2.
Friggin' Iowans.
In like AWS, like
cheating ass, dirty ass Iowans.
But the second time, on some of the reshoots, like Joseph was in SF, and I was since I'm in Boulder, I think I was closer, so I had a little bit of a timing advantage there. So yeah, it's actually something like, if anyone's listening to this, if anyone is enterprising and wants to build a amazing buzzer system that manages latency and everything else, like hit me up, because maybe we'd be interested to work with you on it.
Yeah, for sure.
This almost reminds me of this setup for high frequency trading. There are these very expensive setup for high frequency trading, and there they the companies that have bought those systems, just so that everybody is fairly treated, and of course fairly just among themselves, right? Everybody else is. So the length of the wires that connect the computer to the main switch, those are measured up to the last millimeter to make sure that it is exactly the same. They have the same access to this high frequency, high speed data.
So if you want to go a little bit faster, you can just kind of pony up and
yeah. That's amazing.
You can't. That's what they have made. That okay, at least once you have paid these millions of dollars or whatever it is, then you are in the elite league, and you are treated the same. Among the 10 people.
You get those millisecond trades.
Yeah.
That's amazing. Yeah, it's like basically So that was one of the things that was a challenge. And then the other thing I was like, even once we got all the final footage and everything else, I think that was one of the things that both Phil and Yanni spent a whole bunch of time on, was just matching up, just trying to match up the timing across all these different things was really hard, and it took forever. And then this is just this is actually a bug that we still need to figure out like why this happened exactly. But some of Luna's reflections, you can see, like I'm pointing at, if you look at that arrow closely, the reflection should, like the desk reflections make sense, but the fact that she's reflecting on the floor behind doesn't actually make any sense. So it's like a bug with either. It's most likely our fault. Like we're probably just doing something dumb with how we're
like it's not doing something on the back face, maybe. I don't know.
Yeah, I don't know. But yeah, it was just one of those things where we were like, we didn't fix this one up in time for the final footage, but it was just something that we're working on, just like improving. It's just like getting this quality. There's a lot of these little, I think things like with this kind of virtual production stuff, like small details like this, like definitely enhance things. So can you get good segmentation? Is the scale correct? Is the I think a lot of people in this case like even mess up things like aspect ratio. So you might look thinner or more broad than you should.
You can do that?
Yeah, actually, that could be a feature. We'll make that an advanced feature in
Funhouse mirror mode.
Lose 20 pounds mode, or younger me mode or something. Those were some of the things, but the thing I was gonna say is like both I want to give a shout out to both Yanni on the LightTwist team and Phil, who did an incredible amount of work. And like one of my favorite Easter eggs of all time is this. So I'll play this little clip here.
Yeah, this was the last thing I added into the show.
Yeah. So Yanni accidentally wandered onto the virtual set there, and so we got a little clip of that. And both Yanni and Phil did an incredible mod job. So here's a little dry run from Phil here.
Hello, everyone.
I just thought I'd capture that little moment there.
Hello, everyone. Yeah, you should have seen me recording for Microsoft Build. I think they're gonna put. You ever seen the movie Winnebago Man? I think they're gonna put together a clip of all the times I screwed up.
Oh, nice.
It's very profane.
That's awesome. But yeah, shout out to again, like thanks Phil and Yanni for
thanks Yanni. You know, for sure, like wouldn't have been possible because we were literally editing, you know, the day before the show. Like it was yeah.
And actually that like work was like inspired. It was like thanks to that work, like it all came together. And so we'll love it when a plan comes together.
What's it say?
Well, it says, I love it when a plan comes together.
So am I face man here and you're Hannibal?
I guess like I don't know, maybe then we gotta figure out who Yanni was and others, but
well, Yanni is obviously B.A. Baracus.
That's true, actually. That makes sense. Yeah, and so this is like I'll just show a clip from the show, but yeah, I mean it all came together. It was like it was thanks to despite all those problems we encountered, like we were able to pull it off, and like largely thanks to Yanni and Phil, like helping crank through those issues. So
let's go to Phil for a look at the scores.
Yes, it looks like round one was definitely Vikas's round.
Yeah.
But we've still got 2 to go. Back to you, Luna.
Round 2 is our multiple choice round where each contestant will be put on the hot seat and asked a series of 5 questions with up to 4 answers to choose from. Each correct answer in round 2 is worth 420 points with no penalty for incorrect answers. Let's take a moment to get to know our contestants. Hey, Kat, you're a developer advocate at Open Robotics. Can you tell us a little bit more about that?
I'm the developer advocate for an organization called Open Robotics. You may know us
so yeah, you can see like her hair
as Robot Operating System, ROS, or Gazebo.
A bit messed up there, but so yeah, I mean, it came together and it was pretty. It was like Satya said. I mean, even though I was involved in creating it, definitely like it's when you look at it, it's like kind of hard to like. It's hard to like imagine that it was just like regular footage or composited, using
the seams are way harder to see. You can't see the zipper, like it's
there's some stuff
these subtle things that are going on that add to realism. You don't notice them. So in realism there's this funny thing that you can tell something is not real, but you cannot point to why it is not real, right?
The vibes are off.
There's something off, right? I mean, the brain knows it, but at a subconscious level, but you cannot pinpoint. For example, here you can see that the reflection of her hand that subtly adds to that realism that fools you, right? That it adds to that realism, right? It may still work without the reflection, but that reflection just puts it over just slightly over the edge.
Yeah, and combined with the subtle camera moves as well.
Yeah, like here, there's 2 things. Like, the camera moves, and then you can see the reflection is like it's like the reflection is changing in real time thanks to the game engine, based on the camera position as well. So it's like it's not only that Phil is moving, but the camera's moving, and that's being accurately reflected, which is cool. So it's all like, in a sense, because the game engines are trying to recreate like light, actual physics of light and everything else. It's like or at least like trying to approximate it. You get some of that for free, which is nice.
You can get away with the big fake stuff if you do the little real stuff, like the big lies are easier to swallow if you've got a bunch of little bits of reality in there, like the slow subtle camera moves and the reflections and the way the light actually is pretty close to what the light is in the studio.
And so like
the other thing that was surprising, if you look at the other footage where the camera is not zooming out, it's moving out. It's Luna's footage.
Where it's trucking forwards and backwards.
It's almost moving sideways slightly. Yeah, right there.
Oh yeah, right here. Yeah.
So this one, I would have thought that we are camera motion would not, look, it's not a straight motion, right? It's not moving straight. You can look at the OpenVino and the back end. It's almost, it has a curve to it. And I would have guessed that things will not look real in this segment if you had that kind of camera motion. And I was very pleasantly surprised that, I mean, it's working, right?
Yeah. And there's a trick here that I actually learned from a person that's like, his name's Corey Strasburger. He's, he was like also like just chatted with him early on. He was like basically an expert on virtual production. He built this. You should definitely check out his YouTube channel. It's he created this this metaverse show called Blue, where he's like basically powering like a full avatar character using a combination of like an XN suit plus like an iPhone, and then he's like a virtual production god basically. So he like created this amazing show. But he had this trick, which is like, to your, just to explain one of the things that's like subtle is even if you have a 2D plane and the person is representing the scene, if the plane actually tracks the camera, meaning the plane actually faces the camera,
you just have it.
It actually, so, in the extreme angles, like it won't work. Like if I were to go move the camera, all the way, really close to Luna and then go to, 80-degree off axis angle would be bad. But within reason, it can extend sort of the suspension of disbelief by having that plane rotate to face the camera. So that was like one of the little tricks we did to make that look a little bit better.
Yeah, because it's an old game thing. Billboarding. It's basically what makes. I mean, they've been doing this since Doom. Like the Doom game engine did this as well. It's basically just it's going by where you're facing, and when you have bad guys coming, they're actually tracking you.
Exactly. It's sort of like a thing we can do in the short term until we have a better 3D representation. Like hopefully, maybe later this year. So yeah, I mean, like really, as mentioned in the beginning, like we were, we went through this, and it was like the two things that were pretty inspiring for me were like, one, the final result like looked like, honestly, like better than I expected. Like I was like, okay, this actually looks pretty sweet. Like it was actually, and it was pretty fun. I was a contestant on the show, and it was actually pretty fun doing the game show too, like participating in it. And so I was like, we were, and then actually the issues encountered like were actually like inspiring in a weird way, because I was like, wow, it's like really, there's a bunch of stuff that we hit that were problems, that were things that just looking at it, it was like, okay, it's pretty clear, it's pretty obvious how you might make these issues like go away. Like we could make this better. And the other aspect being like the high-end graphics that we're able to do on like a RTX 3090 or like a nicer GPU essentially is another factor here. It's like, it's something that you can't really do on like even on the latest M1 Max, like, it's not quite at the level, or certainly, not quite there yet, without some significant optimizations. And so really like this inspired the creation of like we're essentially in the on the cusp of having like an MVP of this now. But so we built this, we're basically building a cloud version of LightTwist. And part of the inspiration is like being able to do game shows like we did for OpenCV AI. And so, a couple of things just to talk through here that are, pretty interesting is like, one of the things is that we're looking at having basically having our own front end. So instead of using Zoom and then having like a separate interface for things like the buzzer and other things, having like a single browser interface that all the participants and people that are appearing on camera can go to. And then part of this is also having a real-time component. So you're able to live stream this. And so we have this almost ready. I was kind of, if we had it ready for demoing today, I would have, but not quite there yet. But essentially the other thing is like, we're able to run segmentation in real time, run the rendering pipeline in real time. And so, and even do things like switch between different camera angles, like all at runtime. And so even if you're doing a live, what's called sort of a live to tape scenario, where you don't necessarily want to stream the experience of like the game show fully live, you want to pre-record it. it helps because you're able to composite, essentially see a preview of everything all together while you're recording the show. And so
instead of just having to see it in your brain,
yeah, exactly.
you can actually go, oh, you know what? I just noticed, it's hugely beneficial.
And so, yeah, like what you're able to do is, like see, switch between different camera angles. Like we're working on like enabling things like pre-configuring scenes. So like things like overlays, like some of the stuff you can do in OBS Studio, just making it a subset of those features, making that accessible. And then, like being able to join with just an iPhone. And there's like, not showing here, but there's some of the onboarding process when you're joining in is things like setting your height and your seated height and different elements so you can appear, with the right scale and everything in the scene. And then the other cool thing is like we're actually able to record. There's like a master camera that you're controlling and jumping between. But also having like other additional camera angles that are just recorded off. And so,
it's awesome to be able to just go, give me camera 2.
Yeah, exactly. And so like, one of the major issues that we had was, one of the things that actually we didn't quite hit was like the ability to jump between different virtual cameras and have it be sort of at the same, essentially have it be time synced. And so there's a little bit of like some discontinuities if you watch the previous show, but with this, what we're doing is also recording off multiple camera angles. So you'll be able to cut between like 3 to 4 fixed or even animated cameras that are all time synced as different tracks. And then like the main track that a video producer could be controlling.
And what's awesome about that too is that the multi-camera functionality is built into like Premiere and Final Cut Pro and stuff like that. So you can, it makes it, I will sometimes show people I use Final Cut Pro to edit this stuff, and just the number of pancakes, called a pancake editor because you just got stacks of video streams, and it was there were so many cuts because we had to do things asynchronously that it would have taken half the time if we'd have just had everything time stamped in the same time.
Yeah, I mean, I think it was really like thanks to both of you guys, Satya and Phil, for having us work with you on this. And like I said, it inspired this product. And then actually one other thing I thought was I'm actually pretty excited about is the idea of enabling almost like a new class of like work, which is like remote video production. So part of what we're excited about is like you as the host, if you were like in this LightTwist crowd experience as the host, you're able to run the show yourself if you want. But if you want, you can also have somebody join remotely and just like cut between camera angles, like run the, essentially do all the video production stuff.
So you can actually host the show.
Yeah, exactly. So, excited about that. And then, last thing I was going to mention is, like I said, we're looking for new team members. And so, we're a fully remote team. We are hiring basically anyone that works in the CET time zone in Europe through PT USA. And you just have to basically live in that time zone and have good internet. And that's basically the only requirement in terms of location and place. And so there's no differences in salaries or anything like that. It's just all based on your experience level. And so, we've this is actually the first time I'm building like a fully remote company. So starting to figure out different ways we can get together. And one of the things we've been doing is Rec Room, which is actually pretty awesome. So everyone has a Quest 2, and we've been jumping into do things like laser tag and all these little quests you can do in Rec Room. And like we're, there's a couple founding computer vision engineers, especially somebody with deep learning experience, practical hands-on experience, plus one if you've done things like segmentation or relighting or even 3D reconstruction. And then founding software engineers, so somebody with, especially, we're looking for somebody that has more skill on the back-end engineering side, streaming code, but in general, just a great software engineer. I was going to mention 10K bonus basically right now is what we're offering if you refer someone that gets hired at LightTwist. So if you know anyone or you yourself are interested, hit me up. I'm Vikas@lightwist.com.
Awesome. Thanks, Vikas. And do, I can't, we worked together for what, like 7 years, something like that.
Yeah, that's right. Yeah.
And we still don't hate each other. And so that's kind of, I feel like that's a good, Anybody that's worked with somebody or had a long-term relationship knows how difficult those are to find.
Yeah, that is true.
We have just 3 minutes for questions. I want to cover the question before we run out of.
Yeah, well, let's do trivia.
Yeah.
Let's do trivia real quick here. So, if this is your first time joining us on OpenCV Weekly webinar, or if you just need a reminder, we have a giveaway here. We're going to give away your own custom, within reason, LightTwist set, thanks to Vikas and the good folks at LightTwist, and also a free OpenCV for Beginners course. If you've already taken that course and you win, we'll let you pick something else as well. I'm going to ask 2 questions here. The first one, so get ready to answer in the Zoom chat window only. Zoom only. If you're not in Zoom, you can still hop over opencv.live. So Vikas mentioned The Mandalorian as a big influence on LightTwist's path. What professional wrestler played Costco Reeves on that show? I think I might have finally stumped him with my pro wrestling stuff.
Yeah, people are Googling now.
Yeah, I mean it was pretty popular. Hey, all right, Jeff, you got it. The correct answer is Sasha Banks, Mercedes Castroneves.
Yeah, I'm surprised somebody got that.
Please send one email to phil@opencv.org, and we'll make sure to hook you up with LightTwist. Next question will be for the OpenCV courses, a free OpenCV course. Get ready to answer in the chat here. Who won the first OpenCV AI Game Show? Par-ando. The answer is Vikas.
Yeah, that's right.
Congratulations, Par. Send one email to phil@opencv.org, and we'll make sure that you get your free course.
Yeah. And actually, I can answer one question real quick. I see a question from Dale.
Yeah.
Or I don't know if is there a separate Q&A?
There is, but yeah, go ahead.
Cool. Yeah, there's a question about retakes. I think I think Dale's asking what makes this area more different than studio film retakes. I mean, potentially. I mean, I think the main difference maybe is it's not that the people messed up their. It wasn't like they messed up their lines or something, but it was more that we just didn't have the proper. Like it was more of like a recording issue or like just not being framed properly issue, and that's something that like with a professional videographer, if you were on studio, you wouldn't have that issue. But that's I mean, you do sometimes, but like they reduce the odds of that happening. And so that's something that we think is interesting to try to encode in software to help ensure that doesn't happen.
And there's also the aspect of people wonder a lot if they've never done this kind of work, especially that why are there so many people on the movie set? Like, why is there, why can't that guy be doing 2 things? And it's because of stuff like this. That's exactly the reason why there's an entire crew and it's union, and it's because there's a million tiny little things that can go wrong and will go wrong unless you have somebody specifically paying attention to that thing.
Because are you able to move the virtual set you have? I mean,
what's the weather like out there?
Yeah, I'll see what that weather looks like out here.
Yeah, otherwise it looks like Zoom, right? Just the Zoom background subtraction. But now, you can see that.
You can it's like and there's a couple others here. I can switch to I'll switch to the cabin scene here, and you can see a little
very
fire
Skyrim
in the
very
background.
Skyrim.
Yeah, this is like one of my favorite scenes with just a little bit of things going on.
A little bit of ambiance. Yeah, that's nice.
Yeah,
I would like a little fire crackle in the background too. You got to get that stuff in there.
And this is one of the things. We just have like some controls on like the studio. The coloring and like lighting as well, so that like you can match. So I think I maybe go a little bit brighter or a little bit not as bright maybe. It's fun.
It's fun.
So I have a couple of technical questions. So given that you probably know more about segmentation than any person here, because you've been this is your bread and butter, right? So what alpha matting or segmentation do you think real time for now is close to the state of the art people should look at?
I would say we've looked at robust video matting is like probably the one that I've seen that's like the best in terms of quality, and like that's like one that we're using in various ways, and have like modified versions of. That's one that I'd say is worth looking at. And they do some pretty interesting things in terms of using like recurrent neural networks, like recurrent aspects of the system for temporal stability. Trying to think if there's any. I mean, that's probably the one that I've seen that's most impressive in terms of like details, like hair and stuff. I don't think there's anything else that's like. I mean, in general, like TikTok actually has some. I think both TikTok and Snapchat have differently. Like the sort of other end of the spectrum is like, what can you do when you're much more constrained on device power? And like, honestly, what those two companies do on just like their segmentation. I don't know if I don't think those are published or accessible, but Snapchat Lens Studio is one way to test it out. Like you can do some cool stuff there where you can like
really easy to get started also with Snapchat Lens Studio.
I think that's segmentation. And then good.
Yeah, go ahead. No, you can finish your thought there, and I have.
I know. I was saying like I was hoping like honestly I was kind of hoping to not have to work on segmentation. I was like, I'll just assume that's a solved problem and just go straight to relighting and like 3D reconstruction. But like that was a surprise to me. Is I don't know. Yeah, like I was saying before, like I actually thought it would be more or less solved. Like it would be like, okay, we may have to combine some different approaches or whatever else, but it's like it'll just work. And I think there's still some like competitive advantage or even like upside in like having working more in that area that I've seen, because there's nothing where I've been like, oh, it's just like a perfect algorithm that just works out of the box and does all the things you'd want it to do. At least if anyone in this channel or on this show has heard of one, please let me know, because I'm happy to use that.
I just noticed it's snowing in the cabin.
Yeah, it's getting a little chilly here.
Yeah, so the other question was that between 3D game engines, Unity versus Unreal versus something else, what would you recommend for people who are, what's your recommendation?
So I'd say in terms of out of the box quality, if you have the right hardware, in my experience, Unreal Engine is like just incredibly good for that. Like they have just done an awesome job, and they have a lot more advanced, like a lot more people and energy going into virtual production on Unreal Engine. So there's a lot more built-in sort of mechanisms in Unreal for that. So like that's a good. I mean, if you have the hardware and if you're looking for something higher end, and that could make sense to start. I would probably start there. If you're looking for something more, I mean, just if you want to run locally and like just have like something there, it's like I think Unity. That's probably why for the Mac app we're using Unity, is it just seemed more performance on like at least on Mac hardware. I think my guess is like there's probably ways to tune both in either directions, like both tune Unity for achieving something more close to what Unreal can do in quality, and vice versa, tune Unreal to achieve like Unity level sort of performance on things like M1
I will say, having used both a bit and having played with Unity's high definition render pipeline, you tend to get much more realistic stuff out of the box with Unreal, I would say. But it takes a little bit more it's a little bit more hardcore in terms of getting started with it. Versus Unity, you can more or less drop in, but your lighting and all this stuff is not really going to be, the camera is going to be this looks like a video game, type of thing, versus the much more realistic default cameras you get with Unreal.
Like we're using the HDRP pipeline right now on Unity, and like there's some things that we hit there in terms of getting it up and running. But I would say like if you can get the right, a lot of it is, to be frank, the studio design itself. So if you have like the right materials, like you can see this scene I'm in now, it doesn't look as good as the in terms of realism as the scene I was in the office, and a lot of that's just the materials and the lighting, and there's a couple of things there.
Lower poly.
Lower poly potentially.
What about the cost for the two? Do they, for startups? Cost
Getting startup. I mean, if from a startup perspective, like Unity, actually, Unreal just charges based on like if you cross a certain revenue threshold. So it's effectively.
How do they track that?
Was it?
How do they track that?
I'm actually not sure, to be honest. Like, we'll see when we start rolling in some good money, and then maybe I'll try to Yeah, on the Unreal side, I'm actually not sure how they track it, but on the Unity side, they just do it based on developer seats, and they have like a little army of people that will track you down if they're like, hey, I see you've got 2 or 3 people signing in from the same,
It'd be a shame if something happened to that license key.
They're like polite, they're sort of polite enforcers of their thing.
My wife has been very vocal on the subject of the pretzel monies.
If you're just, if it's like somebody on this webinar, it's just like one to mess around with like virtual production, like that's pretty straightforward. And yeah, if if anyone has an M1 Mac and is looking to do some stuff there, like interact with Unity and play around, like definitely ping me. I'm happy to give you some early access, because it's you can even build, right now what's cool is like you can build your own. We haven't built out a whole customization UX for LightTwist yet, but you can build your own Unity. You can build your own space in Unity editor and then load it into LightTwist and then use it for that. So if you wanted to play around with some different ideas, it's easy to do.
Yeah, and we can. I mean, do we want to reveal what we're working on together next? We haven't really talked about it on the show.
Oh, wow.
Yeah, absolutely. Yeah, happy to.
Yeah, so we're along with LightTwist, the OpenCV Weekly webinar will be going virtual production soon as well. I don't think we're gonna show you anything today, but it's gonna be a lot of fun. It's gonna be an interesting set. It's a different problem to solve virtual production wise than the game show in a lot of ways, but it shares a lot of commonalities, and so it makes a lot of sense for us to use LightTwist, because we already know each other and have worked well together before, but also it's probably helpful for y'all to solve some different problems in our weekly ongoing show.
Yeah, exactly. Like, like I said, it was inspired by our creation of this like cloud version was inspired by the OpenCV Game Show, and like we're setting it up essentially to be plug and play for people doing shows like the OpenCV Weekly webinar. So you feel like 2 co-hosts like in different locations and having guests on and just making it look much more exciting than just 3 of us on Zoom here.
Yeah, hopefully maybe the stretch goal is being able to push a button and have our lower thirds pop in. So I don't have to, I can just stop using Final Cut Pro entirely now. Yeah. Also I forgot a quick shout out to the band that did the interstitial music and the outro music for OpenCV AI Game Show, The Mayflies. I love you, Hank and Jess. We've got a couple of good questions here. We're about 10 minutes past, but everybody got time here to do a couple of quickies?
I'm good.
Yeah.
So Q&A here.
Yeah, so one, we'll say Dinesh had an interesting question I think we can just kind of spitball on a little bit, which is, where do you see use cases for this in news media, in nonfiction, aside from our show? Thoughts on that?
Yeah, I think, in a lot of ways, like this is like, news and like, especially like local news and different media, they already use a lot of virtual production. So if you look at like CNN's, if you watch like CNN's like election coverage, like a bunch of that stuff is actually green screened and virtually produced. Obviously weather, the local weather is like been, sort of a some version of virtual production for a long time.
ESPN as well does a ton of virtual production.
Yeah, exactly. So I think it's more, the way I see it is like, what's interesting about it is it's been done historically, and like, when you have the budget to afford it. But to me, what I'm excited about is like, whether it's with LightTwist or not, is like, I think it's going to give people that are, I guess the thought experiment I always have is like, is there somebody out in the world that's like just as talented as Jimmy Fallon, but they don't have the budget or the the means to like go and build up.
Let's aim a little bit higher than Jimmy Fallon, please.
Maybe not. Yeah, but like it's like, can we give whether it's us or
take that Fallon,
like get them the skill, get them. I guess I'm excited about this idea of people being able to tell their stories, like share ideas, and have their space and their presentation match the quality of their ideas and their stories, and not just be limited by like, hey, I'm creating this in my parents' basement, and like and like that's actually something I'm super excited about. I think that's going to be exciting in that way.
Because still these days, to have a really nice, the streamer set up, right? Yeah, you're talking like 10 grand, like for lights and I've got my like $15 plug-in here, but like seriously, it's still a lot of money to get even just lights are expensive. Like just the kind of, you know, like ring light, a good ring light is, you know, you're going to spend $100 at least. And to be able to really unify that, you know, you talked about this already, but like the vision you have in your head with what you have at hand is really hard to do. And this makes it so much more, so much closer together.
Yeah. I think that's the future of virtual production. And I should say the other thing that's interesting too is I think something, you know, we're not doing in the very short term, but like maybe later this year is like supporting avatars as well. So like, could you, you know, could you have like
stuff?
What's that?
Hell yeah, we need Satya as a VTuber.
Yeah. We could. I mean, yeah, we could try that for the OpenCV Weekly webinar. But I think it's cool because it's like you can also do some really interesting. When you go to a full 3D virtual character, it opens you up to a lot more exciting like interaction between the person, like between that avatar and the 3D world. So. Like
also, I could be multiple characters. I just realized there could be like 3 characters that are me.
Oh, totally.
But none of them are actually me. That sounds fun as hell.
Yeah. So I think it's just like, you know, both. Yeah. That's something that's like gonna, you know, change how a lot of this happens. But yeah. Yeah. Let's see. I'm trying to see what our next question is.
So we've got a great suggestion from somebody here to use the OAK-D's depth data.
Oh
get an effect to 2.5D characters like in the memories from Minority Report.
Oh yeah, absolutely. I think that's that's definitely like something. I think even whether it's using the depth data or using something like that to like having a couple OAK-Ds or similar like OAK-D is actually a great choice. Like, but yeah, basically having a couple of those. Essentially like mounting a couple of those on your, you know, in your space, and they're relatively inexpensive.
Ideally, they'd be rigid, so you don't.
And then you could do like some, not even just like depth, but maybe neural rendering in that case.
Right.
And that would be, I think it's like on the cusp of tractable if it's not already.
Yeah, definitely. I think we got time for one more question here. There's Zach had a pretty long one. Let me try to summarize it here. Was there any consideration to limiting the size of so one of the things we talked about was the little things that make the show seem more real, such as the reflections and the subtle camera moves that you would get if you had somebody literally holding a camera and, you know, moving it around. And one of the things that was different, and this was intentional, I think, you know, on our part, which was you can use those small things to get away with big things. And the big thing is just how huge that set is. You know, there's no way in real life we would ever be able to afford a set that big. Like that, it's you know, it's an entire warehouse, and there's, you know, all these structures in there, and there's LED video panels and whatnot. And Zach's statement was that it seemed it made it feel more VR or you know, more fake to him. But I think that's like good, because we did want to show there's a difference between trying to just make it look as much like real life as possible and trying to go farther than real life. And what we were trying to do was go farther than real life by using those small things to give it the reality.
There's actually maybe, you know, a couple different things. There's a couple steps, or maybe there may be 2 different axes. Like one is like the one axis is like suspension, what I'd call suspension of disbelief, and that one is, I think it's you know, I would argue it's an easier bar in a lot of cases. And then there's like another bar, which is like, it looks, you know, perfectly real. That's a higher bar. And I actually think you know, if you think about like a good example is this Who Framed Roger Rabbit. So Who Framed Roger Rabbit is like an incredible, you know, if you look back on it, it's like incredible. They did some amazing rotoscoping and like essentially segmentation back in the day. But what was interesting is like, you look at it and it's obviously not real, but it was good. The segmentation essentially and the compositing was good enough, and the lighting, that you suspend your disbelief. So you don't focus on, your brain doesn't think about, oh, that's obviously like not a real rabbit and they're not in like a cartoon world. But your brain focuses on the story and the information being like, you know, talked about and communicated, right? So I think in that same way,
and they follow the rules. Like there's a consistency that is very important. And like Who Framed Roger Rabbit, it works because, you know, obviously Bob Hoskins wasn't really getting hit in the head with a cartoon mallet, but it follows the rules of cartoons in the movie, and it's consistent. It doesn't break the rules, and so your brain just kind of takes it as rote.
Yeah, and so I think there's like something. So I think that's the bar. At least even just practically speaking, I think in the short term it's probably easier to get to that level, and then the next level is I think the next level is going to like more perfect realism. I know there's a balance there, I think. But yeah, I'd say like I think limiting the size of the set. I think like there's things we could do for sure to enhance realism, but at the same time you also want the entertainment factor, and so it's like sort of
but
I think
there's an aspect of it too that realism is boring. I already have real life.
You don't want like real,
why am I spending all this money to make stuff? Like, come on. Like you gotta zhuzh it up a little bit. You gotta pump the gas here.
In a lot of ways, like I'm actually excited. Like there's one of my favorite Twitch streamers is Code Miko, and she's like an incredibly talented game developer, and she created this character, and like she does all these like things where it's like it's suspension of disbelief plus like just like amazing interaction. And so
Code Miko is not a real anime person. Like
exactly.
You know that, but that doesn't matter. It's better than real life.
It's like Indian movies. If you look at the movies that are coming out of India, they would never portray realistic. It's not realistic at all, right? People don't go to colleges like the ones they show in the movies. Right. On the other hand, if you look at movies made about India by somebody in the West, they would portray realism as if it's almost depressing to see that how could you even live here, right? And it's just that people want to portray somebody else's realism, not their own.
That's a good point. I think that's true. It's almost it's voyeuristic in a way when it's somebody else's reality. When it's your reality, it's boring. But gosh, so we're about 20 minutes past the hour. Next week, our guest will be. I wanted to get this in before we cut off, but our guest will be Kat Scott. We'll be talking about the just released TurtleBot 4 from ClearPath Robotics. They just dropped yesterday. You can go pre-order those. Apparently, it's got an OAK-D Lite and OAK-D Pro, I believe, in there. Doesn't one of them have a lidar? Or have a laser as well?
I think there's like a separate lidar. That's what I saw.
Awesome robotics platform. It's built on the iRobot platform, but it's got spatial AI power in it via OAK-D Lite, and also the expensive one has a lidar built into it. We'll be talking about that next week with Kat. Same bat time, same bat channel. Satya, you want to take us home?
That's great. Thank you so much, Vikas, for giving us the behind the scene for this competition, helping us actually deliver on this competition, the AI Game Show. So it was really good. Phil, as always, thank you so much for organizing this, and also the AI Game Show. You were crucial from our side to make it happen. And thanks again, as always, our audience for being here. We'll see you next Thursday. And I also want to give a shout out to our sponsors, OpenVino, who sponsored the AI Game Show.
Thank you. If you want to see more AI Game Show, please let us know. Send us an email, newsletter@opencv.org. We love to hear about the stuff we make that you like. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.